Hello my dear warriors, I hope you guys can see me as well as hear me loud and clear. Welcome aboard to the JEE Advanced session with me Shreyas, your physics master teacher. Just few more days left, last leg of your JEE Advanced preparation, and we should do all kinds of questions. So if you have been on this channel for some time, you know that we are doing this JEE Advanced series with different approaches. Last lecture I had done only MCQs, before that array of questions. So many things are coming up just for you guys. So make sure you're a part of this by going ahead, smashing the like as well as hitting the subscribe button down there so that you do not miss any classes. So welcome aboard. Hello IIT Madras, hello Vasant, hello Anisha, Anogav, Hafari, JEE Aspirant. Nice to see all of you. And IIT Madras, let's study together. So making new friends out here. If you're not able to cover a topic and you want to plan for it, I would say break it off in chunks, do the easier parts and set smaller targets, then go from level 1 to level 2 to level 3, then go to mains PYQ, then advanced PYQ. That's the way you should do it, and preferably learn from some interesting source or learn in an interesting way, or try to see and relate it with interesting real life examples so that you are able to complete it. And when you set targets, small targets, and when you achieve it, you build confidence in it. All right, so I hope that helps you cover up the portions, guys. And those of you who do not know me, my name is Shreyas and I'm the physics master teacher. Hello Manjit, hello Aditya, hello Learn Addict, G Sridhar. I hope you guys have been regular on the channel, and I hope you guys have watched the previous videos as well. So thank you for all the likes, thank you for all the love, thank you for all the comments. And if you have not done that yet, I would love to see and hear out from you, because it means a lot. Because that's the only reason why I conduct these classes, because I like teaching, I enjoy physics, and I want you guys to improve. So let's begin with the first question coming up on your screen. Today's questions are basically all the awesome, super duper tricky questions which you will find in JEE Advanced. So here is the question coming up on your screen. Let's try to solve this. We have two stacks of 20 books, each on the ground, have to be arranged into a single stack of 40 books. Well, each book is 2 centimeters thick and has a mass of 1 kg. What work do we have to perform to move the books? So there are two stacks of books and you want to make it into one stack. How much work you need? Believe me, this question looks easy, but many people make some silly mistake. Either they miss out a factor of 2, forget some division, forget some multiplication. So lots of chances of silly mistake. Thank you Jayalakshmi so much. All right, thank you Reddy. Thank you so much guys. Now, these are the stacks of 20 books, I believe. Yes, 20 books each. And they have to be arranged into a single stack of 40 books. So let's try to analyze the situation, because the question says find the work done to perform the books. Now try to understand and move the books. If you want to move the books this way, you are basically changing the potential energy of the system. Why? Because the books were below, the center of gravity was below. Once you move them here, the center of mass has been raised up. So you are essentially changing the center of mass of the system. Do you guys agree with it? So whatever work you do is going in changing the potential energy of the system. And potential energy of any rigid body can be just written down as the mass of that entire body into acceleration due to gravity into the height of the center of mass from the reference level. So I need to find out where is the center of mass. Finding center of mass for this case is very easy, because this is a uniform stack of books. Read the question carefully. You will realize that each book is of 2 centimeters, 2. Like that, there are how many books? 20 books. So there are basically 20 books each over here. Naturally, this height will be nothing but 20 into 2, which is nothing but 40 centimeters. If that is 40 centimeters, I know where the center of mass will be. The center of mass definitely will be over here at a height of how many centimeters? 20 centimeters. So basically you will see that the center of mass is over here, that is 20 centimeters, which is also 0.2. This is 0.2 meters. So I've converted into meters because everything will be SI units. Remember, this is where the center of mass is. The center of mass of these two book stacks is. Now, finally what happens is you push them, all right, into a single stack of 40 books. So there are 40 books in this case. So there are 40 books in this case. So 40 books, each of height 2 centimeters. Total height undoubtedly is nothing but 80 centimeters. 80 centimeters. But their center of mass will be exactly over here. This is where the center of mass will be, and that height undoubtedly will be nothing but how many meters, guys? This will be 0.4 meters. This will be 0.4 meters. Everybody with me on this? Awesome. Now all you need to do is find the work done this was my bad, guys. I by mistakenly wrote this as the work done. This was, oops, sorry. One second, let me just erase this. This was supposed to be the potential energy of the body, not work done. The potential energy of the body will be mgh. M is the mass, g is the gravity, h is the height. So the work done will be basically the final potential energy minus the initial potential energy. Now if you look at the final value of the potential energy, the mass of the entire system, how many books are there? 40 books, each of mass. How much kg? 1 kg. So it will be basically 40 kg. Acceleration due to gravity is 10 meters per second square into height. Height is nothing but 0.4 meters. So multiplied by 0.4 meters. That is nothing but the final potential energy. I hope you can see that. And if you talk about the initial potential energy minus, so that initial potential energy, M, mass is nothing but, if you take any one stack, the mass is 20 books. So 20 books, each of mass 1 kg. That will be 20 kg into G is nothing but 10 meters per second square. And height I just figured out it was 0.2 meters, but there are two such stacks. So I will have to multiply by 2, this one and this one. So that's why into the 2. Now, how much will be the remaining answer? Just you can calculate this and figure this out. So this is 40 into 10 into 0.4. So this will become just nothing but 4. 4 into 4 is 16. So this is going to be 160 joules final energy. And if you talk about the initial energy, just check this out. I will have 2, 2 and 2, 2, 2, 2 will become 8. So I guess that will become 80. So this will become nothing but 80 joules. So hence the total work done will be nothing but 80 joules. 160 minus 80 is nothing but just 80 joules. That's it. I hope this is clear. Very good. Learn Addict Tamil. You guys were quick. Very good, bro. Very nice. Some of you have answered very quickly. Very quickly. Awesome. Good evening, Chinmay. Anjana, I am doing chapter-wise questions for 11th and 12th standard in the Legend and the Ultra Legend series. So make sure you are a part of that, because I am doing the long-term 11th and 12th standard problem solving as well. Awesome. Easy peasy? Okay, great. Many students either miss this too, or they make a mistake in the mass, or they make a mistake in the center of mass. So that's why people end up getting some different answer. Chances of silly mistake in the final exam are high. Otherwise, it was simple. By the way, please join the Telegram channel so that you get updates and the PDF of all the sessions that you have. Let's look at this question now. What is this? This looks like a potentiometer to me. I can see there is a potentiometer circuit, there is a potentiometer wire, there is an external circuit, there is switch, everything is there. In the arrangement shown, when the switch S2 is open, that means this S2 is open, this 15 ohms is not a part of the circuit anymore. Then the galvanometer shows, so this galvanometer shows null deflection when this length is L by 2. So this length is the total length's half value in the first case. When you close S2, so when S2 is closed, then this circuit is complete. Then the null deflection happens at some other point, which is at 5L by 2. The internal resistance of this battery is given to be R, and the EMF of the other circuit is given to be E. That is what the question is. What is the external EMF and what is the internal resistance? First of all, I have already done multiple correct answers questions, Magadam, Akhilesh, in the previous session. So if you go to the channel and see past videos, you will find it. It's already there. You should just search for it now. Now this circuit, does it look like some special circuit? Yes, it's potentiometer, but this is a potentiometer circuit for measuring what? Remember, there are three types of applications for a potentiometer circuit. One is to compare EMFs, where in this part you have two EMFs, you press one switch and see which EMF is more by checking the lengths. E1 by E2 is L1 by L2. Second is to measure the voltage difference between any 2 points in a circuit basically it does the job of a voltmeter. The third application is to measure the internal resistance of a battery. To measure the internal resistance of a battery. So think about it, this is exactly that, where once the switch is open, then the switch is closed and you measure that. In the first situation, S2 is not even a part of the circuit. S2 is not even a part of the circuit because it is open, so is that 15 ohm. So if you think about it carefully, you just have basically when S2 is open, S2 is basically open, this resistor will have no use because there is no current in the galvanometer, no current, null deflection. So it's just like you have this 6 volt battery which is connected one over here and the other one is connected here, and then you have this potentiometer wire, okay, this is having certain length and this is connected to your EMF E and it is going like this. So this is E and this whole thing is basically L. This whole thing is basically L and the balancing length is basically L by 2. Isn't it obvious now? If the balancing length is half, that means half the voltage is dropped here, and the total voltage across the potentiometer wire is basically E. Everybody with me on this? Observe again. With the balancing length, remember this is the balancing length, the current over here in the galvanometer is 0 at null point. This is the null point. So if there is some voltage dropped here, some remaining voltage is dropped here and exactly equal because this is half, so the total voltage dropped here will be basically across the entire potentiometer, which is also going to be E. So can I not say 6 volts plus 6 volts is basically nothing but E, so therefore E is nothing but 12 volts. Everybody with me on this? Equal volts will be dropped across this. Okay, bro has already put up some answer. I don't know whether it's correct or wrong, but this is the first part. So let's see, 12 volts is there at least in 2 options. So obviously this option gets eliminated and even this option gets eliminated. It will be either B or D. Now for the second part, here is what I will do. The internal resistance of that circuit is basically the resistance that is applied in the circuit, in the secondary circuit, to measure the internal resistance into L1 by L2 minus 1. L1 and L2 are basically the balancing lengths when the switch is open and when the switch is closed. You just have to substitute the values to find the internal resistance. This is a standard formula. So the capital R value is nothing but 15 and the balancing lengths, like you can see over here, one is L by 2, one is 5L by 2. So I'm just going to put L by 2 over here and here I'm just going to put 5L by 12, it's not 12, 2, it's 12. Okay, so LL gets cancelled, so I'm just left with 15 into this 2 also gets cancelled with this 12, it becomes 6, this L also gets cancelled, so it will become 6 by 5 minus 1, which is the same as 15 into 6 by 5 minus 1 is nothing but 1 by 5, right? So this is nothing but 3 ohms, I believe. That is the answer. And do I have 3 ohms somewhere? Yes, option D, I suppose. Yes, there you go. So 3 ohms is right over here. So this option also goes off the table. That's how you're going to solve the question. So this is basically, can be asked as a single correct question. Moving on to another question coming up on your screen based on light waves. Okay, so guys, if you feel like, sir, I want to see this once more, or if I feel like, okay, I have to understand this again properly, don't worry. Even a live session can be replayed, and if you're watching this recorded, just pause and take your time to understand any concept. I want to make sure that you guys see good questions in a short amount of time because time is very precious for all of you right now. All right? Okay, no problem, learn Adik Tamil. Now you know how to find the E. The E value can be found even if you do not know much about potentiometer. It was just simple voltage drop in series resistors. Both the resistors, or when you divide the potentiometer equal into half, equal voltages will be dropped across both the halves. That's all. Okay, Devendu Kora, Uma Maheshwari, how about maybe checking your qualifications for which NIT you can get using our V Ekalavya site, or you can use our rank predictor. I had made a video on that, branch predictor. So just put in your details, you will get to know which branch, which NIT you can get. All right, or leave a comment, maybe I will help you out. In the figure ABC are the 3 slits of them individually producing the same intensity of light at point P0. That means this slit produces intensity I0 separately. This slit when opened produces I0. This slit C when opened produces intensity I0. Individually, separately, independently. All 3 of them together will not produce 3 I0. That is the catch, obviously, because these light rays won't reach simultaneously. There will be some path difference between the arrival of these rays, because of which you need to solve the question via interference, understand what is the path or the phase difference between these rays. The funny or the interesting part is that there are 3 rays which are interfering. So maybe I'll have to play around this problem a little bit more than expected. Okay, the question is basically, I think there was one data missing. Oh, this is given. Yeah, BP minus AP. BP minus AP is also given. D is much smaller than capital D is also given. Find the wavelength and the resultant intensity. Find the wavelength, okay, wavelength and the resultant intensity. Let's try this out. The first part of the question. Okay, maybe I have some space over here. Yes, I have. So, BP is basically this length. AP is nothing but this length. Now, this is 2D, this is D. Naturally, this distance will be, by Pythagoras, because this is 90 degrees, this will be nothing but 2D whole square plus capital D square. This distance minus this distance is given right over here. So using this exactly, so BP will be nothing but root of 4D square plus D square minus capital D is equal to lambda by 2. Alright, everybody with me on this? Now the next step is very crucial because you have to make certain approximations. So you need some knowledge of basic maths, and let's use that. Hello, something new. Hello, Vasudha. Good evening, Joshita. Yep. So now how do we do that? Hello guys, everyone. I'm going to use binomial over here. The moment I see some kind of approximation, some kind of neglecting terms, and I see some root and some addition and all of that, I most likely will think of binomial. So how do I think of binomial? Observe this. This whole thing is basically raised to 1 by 2. I can write this as d square, I can take it common, plus 4d square by d square. Okay, I'll just ignore this d square now. I'll just write 1 over here, and I will take basically this d square completely outside. Observe this now. Observe this. Does that make sense? Because if you multiply this d square with those round brackets, d square and this d square cancels, I will get exactly the same thing. The root has been replaced by half. Root has been replaced by half. I'm very good with it. Now this minus d is equal to lambda by 2. So that is the first trick over here. Now let's use binomial approximation, because if you notice, this is a very small term, because it is clearly mentioned small d is much smaller than capital D. So this will be much smaller than 1, especially it is squared. So I can just write this as d square. I can take it out, so it will just become capital D. D square's root will become just d. This will become 1 plus n. N is nothing but half. X is nothing but this whole term, which is 4 times of d square divided by d square. This whole thing minus d is equal to lambda by 2. Just check this out. See if this makes sense. Yep. Kushi, no, this is not for 11th bacha, because these are towards the end of 11th topics. So if you are in 12th, you know this, else you might find this difficult. Now what you can do, just open this bracket up. So this will become d plus this d and d square will get cancelled. So it will become just 2 times of d. And 4 and 2 will also get cancelled. So I just have 2 on the top, and I have d square also over here. And I have this as, I have one more minus d over here. I can see there is one minus d over here, and this is nothing but lambda by 2. This d and this d gets cancelled. So I'm just left with 2d square by d is nothing but lambda by 2. Now I think I had to find out wavelength. Yes, the wavelength will then be equal to, shift that 2 upstairs, 2 2s are 4, and that will be nothing but small d square divided by capital D. So let's see if I have some option which is correct. 4D square by capital D. Yes, that is there right over here, and this is obviously wrong. I have got till here. Everybody with me? Very good, bro. Awesome. Awesome learner Tamil. Now, Ritik, maybe you can leave a comment later on, or you can probably connect with me on my Instagram. Maybe I can help you there. Now, the last part is intensity. Now, this is the tricky part. So, observe now carefully. This data point is very important because that will give away most of the hints. The path difference between B and A, the delta x path difference between B and A is basically lambda by 2. Can you figure out what is the phase difference between B and A? Phase difference is 2 pi by the wavelength into the path difference, which is basically lambda by 2. Lambda 2 goes, so it is pi. What is the meaning of pi? That means they are basically out of phase. They are out of phase. So if you show the phasor, of A, let's say, I don't know, maybe I can show it like this. This is the amplitude phasor of A. And if I show the amplitude phasor of nothing but B, they will have a phase difference of pi radians, that is 180 degrees. This will be B. So A and B will definitely cancel each other out completely. So when all these three lights meet at point P, out of A, B and C, B and A have already completely cancelled out. That means destructively interfered. Destructively interfered. That's it. Now the only remaining phasor will be of C. I don't know where C will be, but C will be there somewhere. So the resultant at P will be only because of C. That's all. Only because of C, nothing else, because A and B have cancelled out. That's it. So what is the intensity of light at point P? A and B cancelled completely. A and B light cancelled completely. So hence the intensity at point P will be only the intensity due to the light source C. All of them have the same intensity of light, which is basically I naught. So hence it will be just I naught. That's it. So guys, where do we have I naught? I think it is right over here. So B and D should be correct. Let's figure it out. Yes, it is correct. For those of you who are wondering about this step, I have used binomial. I have just used 1 plus x whole raised to n is basically approximately 1 plus nx. If you notice, this is n, so half came here. X is basically this term. That's why that has come over there. I hope this is clear. Yes, the phasor approaches are awesome because they help you solve the questions easily, especially in AC, even in waves, sound, light waves, obviously. Hello, Anthony. Nice to see you back, bacha. I'm so glad, learner Tamil. Just by my few lectures, you are able to at least attempt few questions. I will conduct more sessions in the next week also, and even in this week, because this is just the last 10 days before your exam. I'll be doing lots of classes. I'll try to do as much as I can because I have to take care of many things simultaneously. Let's have a look at another question right now. Beautiful question on your screen. Looks very highly complex. Yes, it is. I'm not kidding. But it is actually simple if you have solved, probably the 1990s papers, PYQs, etc. In one of those papers, they had asked one concept. Based on that concept, this question is based. It has been extended from that concept, and IIT people usually do that. They take some previous year concept, they extend it, they pull it, extract it, sometimes combine two things, and they give or make up a new question. So you have a non-conducting sphere, basically an insulator, and there is a cavity at some distance A from the center. There is a charge on the sphere which is uniformly distributed, fair enough. Density, volume density is rho. Particle of mass m, charge minus q, is placed over here, and it is suspended vertically. There is no gravity, of course. Now the force constant, spring constant, is k. Find the time period and the acceleration of that particular mass. So find the time period and the acceleration of that mass, assuming it is right now probably the spring is at natural length. That's what I'm assuming. If it is not given, that's what I have to assume, I guess. Okay, let's try this out. Now before trying this question out, let's try to understand what will happen because the sphere is uniformly charged. See, because the sphere is uniformly charged like this, these charges will definitely create some kind of electric field. There is no gravitation in this. It's not a question of gravity, it's a question on electrostatics, to be frank. Also, now I want you to realize that these charges together will create a field here. If I'm able to find the field, I think I can find the time period, I can find the acceleration, everything. So my first approach will be not to look at any of these things, time period or acceleration. My first step would be to find out what is the field because of these charges. Now you can see there is a cavity, whether it's a cavity in center of mass chapter, whether it's a cavity in moment of inertia, or whether it's a cavity in gravity or electrostatics. The approaches are everywhere same. You take the big mass and subtract the cavity, you subtract their effects, and you find out the remaining masses or the remaining parts, field or force or whatever it is. So I guess I should have one more slide. Yes, I have. Yep. So I will basically say that the field in the cavity region, okay, observe this, the field, just probably write it over here, the field in the or basically the field due to that remaining part, the remaining part will be basically, I would say, the field due to the entire geometry, the field due to the entire sphere, complete sphere, as if it was not having cavity, minus the field due to only the part which had cavity. This is very, very important. Oh, by the way, this is a vector equation because I don't know what will be the directions. The directions may or may not be the same. See if you understood this particular formula. I have not derived it, I just thought about it. Yeah, whatever is the field at any point in this region will be the field due to the entire thing minus the field due to the part which has been removed. You have to remove that effect. So whatever is remaining is the field due to the shaded part over here. Okay. Now what is the field due to the entire sphere or the part which is a cavity? Both are spherical objects. So let's try to assume certain distances. Let's say for example, this cavity center and this center is at a distance of A. Let's assume that if you take any point over here, that point is, let's say, at a distance of small, let's say R1, and from this point, let us just say from the center of the bigger one, oops, one sec, from the center of the bigger one, okay, I'll just say it is at a distance of, let's say, R2. So this is R2 and let us say this is R1. R1 and R2 are the distances from their individual centers. So do I know field as a function of distance from the center for a uniformly charged body? I think so. I'll go back so that I can write something. So whenever I have a uniformly charged body and I want to find the field as a function, of R, the way I calculate that field is nothing but it is K total charge divided by R cube into small r. I hope you remember this formula, standard formula. No info on the radius. Yes, bro. No info on the radius. Let's try to do this. It's a tricky question. Oh, by the way, let me tell you, whatever I'm doing right now, that is a concept which you should know. You cannot think about all of these things in the exam because this was a previous year question. So I think IITs expect that you have solved so many previous year questions so that you have already done all these steps as homework. Okay, this is something which you should have done at home. Okay, so let's see what we can do. Now K is nothing but 1 by 4 pi epsilon naught, and this is Q. This is basically R cube and this is small r. Now it's clearly mentioned volume density. So I see volume density can be brought here. How? Observe. I will divide this thing by 3 because 4 by 3 pi r cube is volume. So I will have to also multiply by 3 to preserve the equality. That's all. Now if you notice Q by 4 by 3 pi r cube, that is nothing but your density, the charge density. This small r is as it is, this 3 remains as it is, and I think this epsilon naught remains over here, right? This is the magnitude of the field as a function of the distance from the center. But if you write it in vector form, the electric field vector and the r vector are in the same direction. So the electric field vector will be rho by 3 epsilon naught r vector. So E vector and R vector are in the same direction. This is the crucial step of the problem. Writing it in vector form, you will see the magic which happens after this step. Everybody with me on this? IIT is completely worth its infos. If somebody has told you, no, it's okay, if you don't get into IIT, you can go to some normal college, they probably do not understand the importance of IITs, or maybe they do not have that experience in an IIT. They have not seen what an IIT is, that's all. So IIT is completely worth it. But yeah, having said that, it does not mean if you don't get IIT, your life is spoiled, your life is ruined, nothing like that. You can make your life no matter from which college you are in. So don't worry about it. So I can then say the electric field due to the complete sphere at this distance will be nothing but rho by 3 epsilon naught, but this distance, that is nothing but R2 bar. So that is the entire sphere's electric field at that particular point. Because of the cavity part, it will be rho by 3 epsilon naught. The distance from the center of the cavity will be nothing but R1 bar. So now I can probably take few common terms like rho by 3 epsilon naught. Yes, these are common. And I have R2 bar. I have basically R2 bar and I have R1 bar over here. Now this is very crucial. R2 vector minus R1 vector. What is that? Well, let me show you some vector algebra over here. If you look at that beautiful triangle, and maybe I can give even that vector A over here by making something like this. Observe carefully. This is a triangle rule of vector addition. Strictly speaking, R1 vector plus A vector, this is triangle law of vector addition. R1 vector plus A vector is nothing but R2 vector. So if you notice, what is R2 minus R1? R2 vector minus R1 vector, it is nothing but A vector. Beautiful. So I can just use that over here and see what do I get. I'll get this as rho by 3 epsilon naught into A vector is nothing but the electric field due to the remaining part. Now this is the best part of the problem. That's it. Most of the calculations are done because if you notice, rho is a constant, 3 is a constant, epsilon naught is a constant. A is the distance of the cavity center from the center of the big sphere. That is also a constant. Entire thing is a constant. So this is a complete big constant. It is not a function of any of the position vectors. The moment electric field is constant in this cavity region, yes, no matter where you go, field is constant inside the cavity. It's constant. Yep. Now what you will see is that if I have to find what is it, time period and acceleration. Do I have one more slide? Okay, I don't have. So I would say this. Observe now carefully. Observe now. For constant field, even the force is constant, and constant force doesn't affect time period. Doesn't affect the time period. That's it. As simple as that. So essentially the time period will be 2 pi under root m by k. That's it. That's the answer, guys. So basically whatever we did had no use. Only for this part, that oh my god, the acceleration, the field is constant, force is constant, it will have no role to play in the time period. Only for that part we did all of this. So if you had solved the previous year question, then you know, oh, I know this, I have solved this previously. The field is constant inside the cavity for a uniformly charged sphere when there is a cavity over there, no matter where you are. Oh, so field is constant, force is constant, so force does not affect time period. Yeah, time period is 2 pi under root m by k. That's all you're going to write. Yep. Oh, according to my vector, is it R1 vector plus A vector is R2 vector? No, it's fine, I guess. Check the arrow mark. R2 vector is A vector plus R1 vector. No, it's fine, I guess. Bro, I think it is fine. Okay. Okay, great. So if this is the time period, you can also find the acceleration. So what will be the acceleration, guys? So acceleration will be force divided by mass. Force will be the charge into the field divided by the mass. So charge divided by mass, and the field is basically this. So that is nothing but density into the A vector or divided by 3 epsilon naught. So that is your acceleration. That's it. Assuming it was at natural level. So there you go. These are the answers. I hope you enjoyed the question and you have smashed the like button, of course. Moving on to the next one coming up on your screen. So there is a particle which has been thrown on an inclined plane, angle of inclination given, speed of the particle given, elastic collision is happening with the inclined plane. The particle rebounds and retraces the same path back at its point of projection. Find the angle of projection with the incline. Beautiful question. No problem, bro. Happens. So let's try this question out. I think the way the diagram has been drawn, it is misleading. It feels as if it has been thrown perpendicular. So it will be better if I erase this, because that's not correct. You will make some random assumptions. It has not been thrown vertically, guys. So I'll just show that maybe it has been thrown at some angle over here with some velocity v over here like this. Great. And I want to find what is this angle. Okay, I'm just going to find out what is this angle theta. That is what the question is. Well, I feel the first step should be to split the components of the velocity and all of that, because inclined plane questions usually you split the components. So this will be v cos theta, and this will be nothing but your v sine of theta, right? This will be v sine of theta, and this particle will go in a parabolic trajectory and it has to retrace the path. Oh, the only way it can retrace the path is if it hits the surface perpendicular. So in an elastic collision, the angle of incidence is the angle of reflection. If it makes any angle, then it will deflect some other way. The only way it can retrace, same principle in light. You would have solved these questions in mirrors or lenses or whatever, where the path of the ray of the light has been retraced. So in those cases, normal incidence occurs. So it has to be a normal incidence question. So maybe oops, did I probably leak the answer? Oops, sorry guys. I think there is no undo. Oh, thank God it is there. Okay, let me just remove this. Okay, so it has to be a normal incidence, maybe something like this. Only then it can go both the ways. Only then it can go both the ways. It has to be perpendicular this way, and its net velocity over here will be this way. Everybody with me on this? Great. Okay, last thing. Acceleration due to gravity. Acceleration due to gravity will be downwards. I can split two components out of it. Okay, so there will be one component here and there will be one component over here. Obviously, if this is alpha, this is also alpha. So this will be nothing but g cos of alpha component, and this would be nothing but g sine of alpha component. Last thing over here, I will choose my axis. I think it's best in our interest to take this as my x-axis, and I can probably make this as my y-axis. Okay, this is your x-axis, this is your y-axis. Okay, I think I have most of the things over here. Now, because it hits perpendicularly, that means there is no x component of velocity at the collision. Everybody agrees over here? So, can I say at the time of collision, basically the collision, can I say the velocity in the x direction becomes 0? Because the velocity hits perpendicular so that it can retrace the same path. Everybody with me? Everybody with me on this? Yep. Great. Just think about it. Yes? Okay. So, can I write Vx in some kinematic form? I think so. How? Vx is ux plus ax into t. Vx is 0. U, the velocity in the x direction initially, is nothing but your v cos theta. The acceleration in this direction actually is g sine alpha, but it is opposite to x. So this g sine alpha is negatively placed. So this will be minus g sine alpha into t. Great. From this, I think I will get the value of the time. So the value of time will be v cos theta divided by g sine alpha. This is one set of equation. Great. Now let's see what else we can do. What else can we do? Maybe I can say that as the particle goes up and comes down over here, goes up and comes down, at the time of collision, can I say the displacement in the y direction is also 0? Think about it. the y coordinate goes up as the particle goes here and it comes back. So the y displacement at this point is also 0. So how about a kinematic equation in the y direction, which is nothing but uy into t plus half ay into t square. Displacement is 0. Initial velocity in the y direction is v sine theta into t plus half into acceleration in the y direction will be g cos alpha's negative component because it's opposite to y. So minus g cos of alpha into t square, I suppose, into t square. Let me just put up a branch over here so that you guys don't get confused. Okay, so this is separate. Great. So let's see what happens. This t and t square gets cancelled, like I can see, obviously. So 0 is equal to v sine theta, and I have minus g cos alpha into t, the whole thing divided by 2. Oh, from this also I can get the value of t. So the value of t which comes out is nothing but 2v sine theta divided by g cos alpha. Great. These two now can be equated with each other. These two can be equated with each other. So let's equate them and see what do we get. So guys, all I'm trying to do is equate this and equate this because both are giving me the values of time. So what will I get? Observe carefully. Okay, v will get cancelled. If you don't see that, so I will write it together. V cos theta by g sine alpha is equal to 2v sine theta by g cos theta. Oh, sorry, not theta, guys. It was alpha. I'm so sorry. 1 second. I think it is alpha. It is alpha over here also. Even here. Yes. Just notice that cos alpha over here. That's when I realized. Okay. So cos alpha. Now let's see what happens. G cancels. Just check this out. This G cancels. V also cancels. So I think I can take sine alpha there. So if I bring this sine theta over here, if I bring this sine theta over here, cos and this is sine. So this is cos theta and this is sine theta. And here I have 2 and this sine alpha and I have this cos alpha over here. And I have this cos alpha over here. Fair enough. Let's try to see what we can do. This is nothing but 1 by tan theta. This is nothing but 1 by tan of theta. And this is nothing but 2 times of tan of alpha. Interesting. Everybody with me on this? That's what I have got till here. Great. Now, can I somehow find out theta from this alpha? I believe so, because I already know the value of alpha. I just need to find the value of theta, guys. Most of my job is done because I've got 1 by tan theta is 2 tan alpha. Observe this. Okay, so do I have one more? No, I don't have more slides. So let me just try to do it over here only. How can I do it? Because look over here, alpha is sine inverse of 1 by root 3. Alpha is sine inverse of 1 by root 3. How about making a small triangle over here like this, where this is alpha. Sine of alpha is 1 by root 3. Sine alpha is opposite side by hypotenuse. So this is root 3. Naturally, if I make this triangle use Pythagoras, root 3 square is 3. 3 minus 1 is 2. Root 2. So this will become root 2. So I can write the value of tan alpha right from here, from this beautiful triangle. So let's see what do I get. So I'll get this as 2 times of tan alpha. Tan alpha is opposite by adjacent. So this is 1 by root 2. So basically this will come out to be root 2. Hence tan of theta will be 1 by root 2. Beautiful. Tan theta, I got it as 1 by root 2. If you look over here, tan alpha is also 1 by root 2. Tan alpha is also 1 by root 2 and tan theta is also 1 by root 2. From all of this, what did you get? Theta just comes out to be alpha. Theta just comes out to be alpha. So the value of theta is exactly sine inverse of 1 by root 3. There you go. Yes, it is sine inverse of 1 by root 3. Same thing. Just check this out. See if this is fine. Isn't it a beautiful question? So the physics part was here and here. This part to understand, okay, in x direction the velocity never exists because it has hit perpendicular. The second thing, yes, when it goes up and comes back, there is no y displacement. So I got 2 equations, solving them, I just equated, I got so many things got cancelled out, and I got a trigonometric relationship. So I just solved this trigonometry, I just drew this triangle, because I know alpha is sine inverse of 1 by root 3. So from that I figured out the missing side, and that helped me solve the question. That's all. Okay, beautiful question, guys. Yes, and yeah, to design this question is very, very challenging. I mean, to come with theta is equal to alpha will not happen for all the thetas. So yes, it's a beautifully designed question. Moving on to the next question. Well, I hope you can see this diagram. I think it's a thermodynamics based question. Oh, there are two paths. Now path, so this is initial, this is final, I and F. Paths shown are this one. I hope you can see the arrow mark. A to B, B to C, C to D, D to F, or from here like this, I to F, G and E. Both the paths are there. Now in path 1, this is the path 1. There is an isothermal expansion, then there is adiabatic expansion, then there is isothermal compression, and then there is adiabatic compression. Work done is all given in magnitude. In the second path, nothing else is given, but the option says find the internal energy in the path 2, heat transferred from A to B, internal energy change in the path D to E, that means from here to here, and change in internal energy in path 2 is this much. Okay, I think one of them might be correct. I don't know. Let's see how to solve. Okay, I think I should get rid of these options. I know it's all got to do with internal energy and heat and all of that. So let's try to understand for this path, that is here to here, here to here, then this to this, and this to this. Okay, so for path 1, okay, the internal energy change from initial and final position, right from here to here. By the way, it is independent of the path, whether I go like this, or any other path, it will be the same, will be the change in the internal energy maybe from A to B. I can add all of them because I can see work done is given for everyone from A to B, B to C, C to D, everything. So maybe I can write work in terms of internal energy somehow. Let's see if I can do that. Delta UAB plus delta UBC plus delta UCD plus delta UDE, of course. Okay. Now, how is internal energy related to work? Well, that's the first law. First law, Q is delta U plus work. If Q, remember, Q is basically delta U plus work. Delta U is Q minus the work. Great. So let's start writing everything down. So it will be nothing but Q from AB minus the work. That's the first case, from A to B. Okay, let's see what and all I will get. Plus again delta, sorry, that will not be delta, that will be Q. So Q from B to C minus the work done from B to C, then plus the Q from C to D minus the work done from C to D, plus again the heat from D to E, I suppose, minus the work done from D to E. Great. Now read the question carefully. I think some are isothermal, some are adiabatic, so things will be easier. See, from this point to this point, A to B, I think it is clearly mentioned it is isothermal. Observe this. This is isothermal. This is basically isothermal. Then the next one is adiabatic. This is basically adiabatic. Next one again is isothermal. Observe. This is again isothermal. And the last one is again adiabatic. So this is adiabatic. I know what happens, guys. In isothermal, I don't even think I should find this out, because I know I don't even have to do this, guys, because I know in isothermal this delta U term itself is going to be 0. This is itself going to be 0. Do you guys agree with that? Same thing for this guy also. I don't even have to calculate the work or anything. I know that delta U isothermal is going to be 0. Only things left is these two. Everything left, only thing left is over here, Q minus work for both the adiabatic process. But for adiabatic process, I already know the heat absorbed or released will be 0. So I don't even have to write these things. So I can just put up 0 over here and 0 over here, because it is adiabatic process. Everybody clear till this point? Done? Okay. So what I am left with is only two terms. Great. Work done from B to C. So the second part, it is 40 joules. So that is basically 40. Okay. Minus the work done from D to E. That's the last part. That's 25. Oh, but wait a minute. It's compression. It's compression. So when it is compression, it is negative work. So I'll put minus of 25. Great. So I'm just going to get this as minus 40 plus 25, which is minus 15 joules. That's the change in the internal energy from initial to final, be it path 1. So be it path 1 and both 2, because it is a state function. Because it is a state function. So it doesn't matter whether you go like this or whether you go like this. So do I have an option there? Let's have a look. Change in the internal energy in path 2 is minus 15. Change in the internal energy is plus 15. Yes, this is correct. This is obviously wrong. Yes. Do you see that? Everybody with me on this? Everybody with me on this? So this option is correct. This option is wrong. Whether you go like this or whether you go like that, it's the same thing. So I got that. Now, what are the remaining things? Heat in AB, internal energy in DE. Heat in AB. Okay, let's try to see if I can find out heat in the process A to B. Can I do that somehow? Maybe. Let's concentrate on A to B path. A to B path. So heat in A to B will be delta U in A to B plus the work done in A to B. A to B path is isothermal. So this, if it is isothermal process, obviously this is 0. So it is only going to be the work done from A to B. Work done is 50. So this is just going to be 50 joules. Yes, it is 50 joules. This is correct. Definitely. Heat is 50 joules. Next, last thing is nothing but probably internal energy change in DE. In D to E is minus 15 joules. Let's try to see that. Last part is basically an adiabatic compression. So the Q from D to E by first law is delta U from D to E plus the work done from D to E. Heat, because it is adiabatic, because it is adiabatic, the heat will be 0. So that will be equal to delta U from D to E plus work done from D to E. The work done is 25, but it is compression. Compression word is important. That is why it will be minus 25 joules. So if you take that on the other side, delta U from D to E will be 25 joules, of course. I don't think it is matching. It is said to be minus 15. So this option is definitely wrong. Okay. Let's have a look on the correct answers. Yes, only option A and B is correct. C and D were the wrong answers. That's how you solve this multiple correct question. Did you love this question, guys? Complete question based on the processes knowledge. If it is isothermal, adiabatic, isobaric, isochoric, what is 0, what is not 0, what is work, what is heat, what is internal energy. Also the first law of thermodynamics, and also the concept of state function and path dependence or path independence. So all these concepts combined over here in this thermo question. Moving on to the next one coming up on your screen. Shall we do this? What say, guys? Beautiful question. Look at this. There are some wires, I believe. They are arranged in hexagon form, and the wires are going perpendicular to the plane that you are able to see. See, these wires are going in the plane of the board. Like this one, this one, this one, this one are coming out of the plane of the board. What is the magnitude and the direction of the field at the point P? 12 consecutive lines are shown to show the directions. So let's try to analyze this. First of all, I know the moment there is any wire, okay, which carries some current, I know there will be a magnetic field around it, and the magnetic field is basically like this. And you have to use your right hand thumb rule to figure out the direction. So this right hand thumb rule is very essential so that you are able to see whether it is clockwise, anti-clockwise. If the current was, let's say, this way, then I know the magnetic field lines will be obviously like this, like this, like this, and like this. This is how it will look like. Refer to these diagrams because it will be useful for solving these questions. This is where the current is going inside. That means when the current is like this, and this is when the current is coming towards you. So the current will be basically this way, coming towards you. Okay, observe now. carefully. Now, if you look at maybe let's say this one, let's look at the exact opposite wire because maybe they might cancel, maybe they might add, who knows. So let's try that out. If I'm considering this wire and this wire, this wire and this wire, because of this wire, the current is coming towards you. The field lines will go like this. The field lines will go like this anti-clockwise. So over here, I feel that the field will be in this direction. Okay, exactly perpendicular, it will be going like this. Because of this one, again, they will go anti-clockwise. So it will be going like this. So at this point, it will be exactly in this direction. Oh, beautifully, they are just cancelling out each other. They're just cancelling out each other. Do you see that? Okay, great. Let's try something else now. Maybe these two. Because of this, the cross one, the current is going inside, so clockwise. So the field will go like this. So at this point, the field will be in this direction. And because of this guy, the current is coming outwards. Hold your thumb this way. The field will go like this. The field will go like this. So at this point, again, the field will just add because of these two wires. Just check that out. Both will have the same magnitude. I can just call them as B1 and B1. Excellent. So they are just adding up. Next one. Let's try to go to maybe this and this. It will be interesting to see. Again, this is cross. This is also, no, sorry, this is dot. Because of the cross, the field is going, sorry, the current is going inside. The magnetic field will go like this. So the field will go like this. At this point, the field will be in this direction. Okay. Because of this, it's a dot. The current is coming towards you. Current is coming towards you. The field will go like this. So the field will go like this. So basically at this point, again, it is just helping it out with this field. So again, magnitude wise, this will be also B1 and B1 because all the currents are √3 amperes. Distances are also same. So the green one got cancelled. The yellows, the dark and the light yellows, both have got added. Do you see that, guys? Everybody with me? Sir, please explain again, why won't they add up? This is dot, this is also dot. Because of the dot, what has happened, if you see the field lines, bacha, so the field lines will look like this because of this wire. It will go this way. For this wire, again, the current is coming towards you. If you see the field lines, it will go like this. It will go like this at this point. So both the fields due to these two will cancel. But this is cross dot, cross dot. So when it is cross dot, it is adding. When it is the same direction, then it is cancelling. That's what has happened over here, bro. I hope this is fine. Can we move now to the final part? So guys, I feel that the resultant will be exactly this one. This will be exactly your net field. Now finding net field is simple because I know what is the total angle between them. The total angle between them, it is nothing but 60 degrees. It is nothing but 60 degrees, right? Because look at this. This is an equilateral triangle. This is 30 degrees. This is also an equilateral triangle. This line will be 30. 30 plus 30 will be 60 degrees. So you just have to basically find the resultant. So it is nothing but root of 2b1 square plus 2b1 square plus 2 times of 2b1 into 2b1 cos of 60 degrees. That's all. And b1's value, what will be b1's value? It's not that difficult. b1 will be mu naught into the current by 2 pi r. This value of the current, you're just going to put it as √3 amperes. √3 amperes. And the value of r, I believe you are going to put it as 3 centimeters. 3 centimeters, which is also 3 into 10 to the power minus 2 meters. Why 3 centimeters? Because this to this point, these sides are all the sides of an equilateral triangle. 3 centimeters. 3 centimeters. So the distance of that point will be 3 centimeters. That's it. So you find this, substitute, you will get the answer. I'm not doing the calculation part. You do it on your own. Obviously, the net field is in the direction of 9. Yeah, somewhere over here in the direction of 9, not 8. It's closer towards 6 o'clock or closer towards 10. So it is going to be along 9. So let's see. Yes, it's along 9. And the answer comes out to be 40 microtesla. Is that okay, guys? You will be able to do this? Give me a thumbs up if you will be able to do this calculation. Yep. You substitute the value of mu naught also. What is the value of mu naught? Everybody knows. 4 pi into 10 to the power minus 7 SI units. Give me a thumbs up, guys. Come on, for all the efforts that we are taking for you. Yeah, will you be able to do this much? And I hope you understood this visualization based question. Completely visualization based. Solution wise, not very lengthy. It's decent sized only. Okay, let's move to one more question, guys, coming up on your screen. This is also a very, very tricky question. Many students make mistakes. There is a spring of constant K and natural length 3I0 or 3L0 cut into two parts of natural length 2L0 and L0 respectively. Each of these springs is connected as shown and just left on a smooth surface. The spring mass system is just left and connected to a wall over here, yes, and the options are right over here. The equilibrium distance, it cannot be in equilibrium. The spring force constant is. Okay, let's worry about the equilibrium part later on. Let's probably worry about the spring constant first. Okay, so if I have a space maybe, okay, so maybe I can just do it here only, that's fine. Okay, so if I have a long spring, okay, and it has a spring constant K, if I now divide it into two short springs like this and like this, what will be the spring constants? Here is the logic. Remember, these two springs are in series. So actually if this is K1, this is K2. And remember, spring constant is always inversely proportional to the length. Spring constant is always inversely proportional to the length. So K is basically always inversely proportional to the length. If this length is L0 and if this length is 2L0, naturally, think about it. If this is L0, this is 2L0. This spring constant will be twice of this guy. So K1 will be basically twice of K2. K1 will be basically twice of K2. And when you connect them back, you will get back the original spring. So these are springs in series, that's all. So I can just say 1 by K1 plus 1 by K2, these are springs in series, will be 1 by K for series combination. That's all. Now solve this, guys. You are going to get what is K1 and K2. K1 is 2K2. So this will be 2 times of K2 plus 1 by K2 is equal to 1 by K. Take the LCM and all that sorts. So see what you guys get. So this will become nothing but 1 plus 2 by 2 times of K2 is equal to 1 by K. So basically 2 times of K2 will be nothing but 3 times of K. So K2 will be 3 by 2 times of K. 3K by 2. And K1 will be twice of K2. So it will be nothing but 3K. So these are our spring constants, K1 and K2. Great. So the force constant of the short part. Yes, the short part, which is K1. This is the shorter one. This is the shorter one. This is the longer one. These are the spring constants. Okay, learn Arabic Tamil. Maybe I can answer your question towards the end, or you can leave a comment. Now comes the equilibrium part. Why the hell will it be in equilibrium? A lot of people will not be able to understand the question only. Why will the spring mass system be in equilibrium? Because there are springs only on this side. It's a smooth surface. There is nothing pulling it. Now I'll tell you why it will be in equilibrium. Observe carefully. You might probably miss why that thing is actually experiencing two forces. Observe. Forget this diagram completely. Just imagine this. Originally, one of the spring has a length of L0. The other spring has a length of basically 2L0. Now both of them are attached to a wall over here. Now these two ends are connected to this mass. So if you pull this spring and connect it to the mass, obviously this spring will get elongated. This upper one, the smaller one, will get elongated and it will try to pull this mass. So as soon as it tries to pull the mass, this spring will get compressed. This longer spring will get compressed and it will apply a force to push it away. So there will be a force that way. This spring on the top will be pulling it. Now do you see there are two forces balancing out each other? Yes, even when I saw this question, I thought something was wrong. I was like, what the hell? How are these two masses in equilibrium? How can this surface be smooth and still be in equilibrium? Was there some electric field, magnetic force? I tried to see everything, and then I was like, okay, maybe I'm missing something. And then I saw, oh my god, the lengths are different. And when I saw this diagram, and then I understood, oh my god, these springs, one of them will be elongated, one of them will be compressed. In fact, in the equilibrium condition, this is what you're going to see. This spring will be probably slightly elongated. This spring will be slightly compressed. Both of them are connected to the same mass. Now it is very apparent. Obviously, you can see that this point is now here. So it has been extended by x. And this point is now here. This point is now here. So it has been basically compressed by how much amount? Well, that we can find out, because I know this is nothing but L0 itself. L0 to L0, this is L0. So think about it. If this spring extends by x, this point, if it has to come here, this distance will be nothing but L0 minus x. See if you guys understood this. It's a beautiful, beautiful concept. Again, this spring was shorter, this spring was longer. If you connect this point to this block, imagine over here, and you bring this point over here, this spring will get elongated. The smaller one will get elongated. So because of which it will pull it. The moment it pulls, this spring will get compressed, so it will push. So this block went here. Now, finally, when it is at equilibrium, you can see this point is actually here. So this smaller spring's extension is x. This point is here. So this distance will be L0 minus x. That's all. That's the compression. Now we will apply the forces. The force on this one will be here. The force, sorry, it's pulling it, my bad. It's going to be pulled. So I have to show a force like this. And this will be pushing it. So a force like this at equilibrium. This is all at equilibrium. And this force will be this K1 into x. And this force will be nothing but K2 into the compression, which is L0 minus x. So at equilibrium, both of them should be balanced. What was K1 and K2? K1 was 3K. So 3K into x will be K2. K2 is 3K by 2. So this was 3K by 2. 3K by 2 into L0 minus x. K goes, 3 goes. So x is equal to L0 minus x divided by 2. Bring that 2 on the upper side. So 2x is equal to L0 minus x. Bring it over here. So this will be 3x is equal to L0. So naturally, x will be equal to L0 by 3. The extension is L0 by 3. So let's try to see whether our options match. They cannot be in equilibrium. This is wrong. This option anyways was correct from here. Out of these two, the distance of the block from the wall. Oh, the distance of the wall from the block. So that distance will be not just x, it will be x plus the original L0. So L0 plus x is the distance of the block from the wall. So that distance will be L0 plus x. That means it will be L0 plus L0 by 3, which is 4 times of L0 by 3. So is there option like 4 L0 by 3? Yes, it is there. Naturally, this will be wrong. That's how you solve this. Beautiful, beautiful question. I'm loving it. The concept of how it can be in equilibrium was the crazy part. Also, dividing the springs, cutting the springs was the other concept, and you learned that spring constant is inversely proportional to the length. You can join these two springs together so that you get back the original spring and stuff like that. You can get the original spring constants. Great. So that is the answer. Moving on to the last question, I suppose, of today's class. This is also one of the best questions and you are going to enjoy this. Okay, ready for it? A plate of capacitor C, charge Q, and the other is neutral. The capacitor is now connected to a battery. Now the total charge on both the plates, I think I had put a diagram for this. Okay, so this is a capacitor, guys. This plate has a charge Q. The other plate does not have charge. This kind of question is very rare, but if it comes, it will be crazy because a lot of people will be completely blown away because they would not have studied a simple object like a parallel plate capacitor in very detailed manner. And IIT people will exactly target that concept where you miss the distribution of the charges. What is Q is equal to CV? You'll start questioning even the most of the basic equations. Observe now. So there is a charge on only one plate. The second plate is not even charged. And now you connect this capacitor to a battery like this. Now the question is, what is the total charge on both the plates? Basically, what is the charge on this plate? What is the charge on this plate? At first glance, it looks like, what kind of question is this? Isn't it simple? You have connected a battery over here of, let's say, V volts. This capacitance is C. So there will be some charge over here. There will be some charge over here. And we know that the charge on a capacitor, the charge for a capacitor, Q is equal to CV. So I think this will be plus CV, this will be minus CV. But that's not the answer. That's not the answer. VS Kaushal, JEE Advanced cracking via partial drop is very difficult, but it is possible. Reason being, JEE Advanced is obviously a tough exam. You need to devotedly study, focused. You should have a lot of focus. You should have a lot of problem practice. Plus, when you are in a college, the college attendance and college practicals, college events will disturb you. And plus, you need that coaching and all of that. You will miss out on all that. So it's very difficult, but it is not impossible. Now, what do we do? You'll be like, sir, it is CV. No, that is not the answer. Trust me. That is okay if both the plates did not have any charge. Here, one of the plates has some charge. That makes a huge hell lot of a difference. Now, when I say Q is equal to CV, what exactly does that Q exactly stand for? Do you know that? Have you ever seen that? If you remember, the charges which are there on a capacitor are always on the inside. You usually do not see any charge on the outside. Outside charges are zero, the charges are only inside, and that's why you have some kind of an electric field between the plates, and there is no field outside. The entire energy is stored within the capacitor. So there is plus Q charge here, there is minus Q charge here. So that Q always refers to the charges or the magnitude of the charge on the inner surface of the plates of the capacitor. Great. Now what about outside? Well, I do not know anything. In fact, since the capacitor had some charge initially and that too asymmetric, so maybe it's better to assume some Q1 charge here and some Q2 charge here. Now observe one thing. What has this battery done? This battery's job is to just pull out a charge from here and push it over here, or to pull out a charge from here and push it here. As such, it has not created any charge, nor has it destroyed any charge. Because if it pulls out a charge from here, it's going to push it over here. So the charge of the system should be conserved. So conserving the charge, conserving the total charge on the capacitor. Let's see what do we get. Conserving the total charge on the capacitor. I will say Q1 plus Q2 plus Q minus Q is equal to Q plus 0. See this. Q1 plus Q minus Q plus Q2 is equal to Q plus 0. That's it. So let's see what do I get. I'll just get Q1 plus Q2 is equal to Q. Interesting. Now what next, guys? Yes, Aaron, plus Q. So what do we do now? What's the last step now? Think about it. Is there anything left that we can do to find the values of Q1 and Q2? Because I still have one more equation to make. If I get that one more equation, then my job is done. I can find Q1 and Q2. Then I can find the charge on each plate. I think I can do one thing. I'll tell you what. Do I have one more slide left? No, I don't have. Okay. So here is what I can do. Maybe if you look at any point inside the plate, the net field must be 0. Agree? Net field must be 0. So how about using that concept? So if I take any point inside over here, the net electric field due to all the charges should be 0 because it is inside a conductor. let's see who and all are giving fields. Obviously, there is an electric field because of Q1. This Q1 charge is right over here. Will give a field like that. So at this point, the field will be towards the right side. So there will be a field due to the charge 1. Due to the charge 1. This positive small q charge will give a field like this. So on left side of it, the field will be towards the left side. So there is one field due to that q charge. Maybe I'm just going to call it EQ. See if this makes sense. These negative charges will create an attractive field. So at this point, these negative charges will create a pulling field towards the right side. So there will be another field due to the negative charge. Great. What about this Q2? This Q2, because of that, think about it. These charges will give a field like this, outward field. This field will pass through this point towards the left side. So there will be a field like this due to the other charge. Now the best part is the field due to plus q and minus q will cancel, like you can see over here. So in fact, I can put it right over here. E1 is towards the right side, minus E2 is towards the left side. Then you also have the electric field due to Q towards the left side. So I think I should put a minus sign over here. Just one sec. Yes, minus side, and plus the electric field due to minus Q towards the right side. Their entire sum is 0. These two fields will anyways cancel. Q and Q will cancel, and their entire sum is 0. So from this, I just get electric field due to 1 will be equal to the electric field due to 2, but in the other direction. If their electric fields due to charge 1 and charge 2 are same, areas are same, it naturally implies charge 1 will be equal to charge 2. Charge 1 will be equal to charge 2. If charge 1 is equal to charge 2 and charge 1 plus charge 2 is Q, that also tells you one more thing. So I'm referring to this equation now. This is an important equation and this is an important outcome. So from these two equations, I will get Q1 is equal to Q2 is equal to capital Q by 2. Beautiful. I got Q1, Q2 both are equal. So hence it should be Q by 2 each. I think now my job is done. So peacefully now I can mark the answer, hopefully. So finally, the charge on the left plate, that means it includes everything. So it includes Q1 also, and it also includes that Q. So how much will it be? Just check it out. Q1 is Q by 2. So this is Q by 2, and the small q is CV. So it will be plus CV. So this is the charge on the left plate. Similarly, the charge on the right plate, will be nothing but Q2 plus, actually minus, because there is a negative charge there. So minus that Q. So you are just going to get that as Q2 is Q by 2. So Q by 2 minus CV. So that is the charge on the right plate. So that's it. I think that is my answer. This is exactly what we were supposed to find. There you go. Q by 2 by plus CV, Q by 2 minus CV. There we go. That's it. Such a nice question, but such a small diagram. Such a simple question. One battery, one capacitor can trouble you so much. So don't look for very long questions. Don't look for, there was a question where 100 capacitors were there and we had to find equivalent capacitance. One capacitor can trouble you for a long time. Remember that. Direction of E2. See, this is charge 2. This charge 2 is going to produce fields like this. So at this point, this field will travel left side. So hence E2 direction is towards the left side. I was talking about the left plate. So this plate that I was drawing was the left plate over here. Is that okay? Understood? Can I directly read NCERT? You can read, but I prefer not reading NCERT directly. I prefer reading HC Verma for all the students out here. Okay, so this is your previous year question. I hope you will be able to solve it. I have put up the solution on the next slide. I'm not going to show it to you. Okay, and if you want to still join the Eklavya and you want to access the quality content, quality lectures, even in the last moment, make sure you join it, because Eklavya is a free program and you will get so many things. Even in the last few days, you can learn so many things. You will attend so many discussions. You will give mock tests. You will see the rank prediction. You will do the test analysis. Also, doubt solving is going to happen. And you are also going to see theme-based tests and test discussions happening throughout the last few days. Also, strategies and tips sessions by the experts are going to happen. So I hope you enjoyed this class. I know this was a difficult class, but that's how the exam is. You cannot say, oh, I'm not going to solve the difficult questions, I'm going to solve the easy ones. But in the exam, you're going to see these conceptual questions only. Thank you guys very much. This was Captain Shreyas signing off. Leave your comments. I would love to read them. Smash the like button, share the joy, spread the love, and also make sure all your friends also are part of JEE Enlite, even your juniors. Thank you very much. Hasta la vista. Captain Shreyas signing off.